Okay, this morning I'm going to experiment with some different sized props on the Y6. There is a lot of discussion online, has been for many years, about what is the most efficient prop setup for coaxial systems where you have one prop above the other. A lot of the discussion says you should have an extra inch of diameter or pitch on the bottom prop because it is spinning in the disturbed air from the top prop. Therefore the bottom one is less efficient and needs more pitch or diameter to produce the same amount of thrust. But then I've also seen other people who swear that having a larger prop on the top is the best option. But then there are also people who'd say that the difference is so negligible it's not really worth it, and the convenience of using the same prop top and bottom is what you should go for. So these are again for 9x4.5s. I've got some 10x4.5s in the bag. I'm going to try flying the 9s top and bottom, then I'll try 10s on top, 9s on the bottom, then I'll try 9s on top, 10s on the bottom. Now unfortunately I cannot get the current meter on this thing to work, the hex mini power cube thing, so I can't actually measure current draw. But what I do have is a charger, so I can fly an auto mission, or I hope I can fly an auto mission if it works, and then charge the pack back up and take a note of how many milliamp hours the charger puts in. So this is 9x4.5, which is what I'm used to. It's what I tuned it on last time. I'm now going to say auto, and hopefully it will then fly a circle that I uploaded the waypoints for last night and won't just drop out the sky. So it should fly out over that way and then begin a counterclockwise circle, 40 meters diameter and 30 meters off the ground, in theory. Okay, so it's now flying to the second waypoint. That seems to be working. Yeah, that seems to be working. So it's going to fly this counterclockwise circle. It's got 8 waypoints in it. That's waypoint 4 it's done. It's going to 5. These missions, you can upload the waypoints from Mission Planner on your computer and then just activate it on a switch. You can do them dynamically or live if you have a ground station with you. I imagine that Q Ground Control probably does them as well. Now what it should do at the end is stop and loiter, I hope. Ready to grab control. Yeah, it's going to loiter. So I'm going to drop back into loiter mode and now bring it home.
Motors disarmed.
Now of course it hasn't been tuned on these props. Right, auto mode. I don't think we're actually going to see any reliable conclusion here. I think without a current meter and without retuning it, it's just going to be too unscientific. Loiter mode, and let's come home.
Motors disarmed.
Auto. Apparently the pitch and roll axes are ignored in auto mode, but the yaw controls aren't. So if you want to, you can manually point the drone as it flies, a bit like in super simple mode. So if you have a fixed camera that faces forwards, you can manually point it inwards at what you're circling around. Apparently, I've not tried that. Maybe I will try that next, just for fun.
Motors disarmed.
Okay, and here are the highly non-scientific results of this morning's little experiment. In the first flight with the 9-inch props top and bottom, we had a flight time of 2 minutes 27 seconds and we consumed 766 milliamp hours of charge. Second flight with the 10-inch props on the top and 9-inch on the bottom, very similar flight time, 2 minutes 29 seconds, and a very similar amount of charge consumed at 732 milliamp hours. That is so close that it's within the margin of error. We can't really draw any meaningful conclusions from that. Third flight with the 9-inch props on the top, 10-inch on the bottom. Again, very similar flight time, 2 minutes 28 seconds, but this time only 675 milliamp hours consumed. Now, on first glance, that might look like enough of a difference to draw some sort of conclusion from. However, when I got home, I realized I'd made a fatal mistake in the setup for this experiment, which was bringing a different charger to the field than I'd used to charge the two packs originally. So the first two flights were performed with packs which had been charged on my Turnigy reactor at home. The third flight was once I had recharged those packs using the ISDT in the field. And if there was any discrepancy between the finishing voltage of the Turnigy and the ISDT, that could obviously completely skew the result for that third pack. So I think the next stage is to repeat the experiment using the same charger, and I think I will also use some takeoff and RTL commands in the auto mission, just so that the flights are absolutely identical, and those involve me manually piloting at the beginning and the end. But anyway, I think it's worth investigating. It doesn't take too much effort, and I think with a more scientific experimental setup, it might actually give me some meaningful results. But for now, I will leave you with something I discovered about auto mode, which means you can have some fun and make your drone look a bit like a spinning UFO from the 1950s.
Okay, we are going to see what happens when we go into auto mode, have the drone fly a waypoint mission, and then give it yaw stick commands, because apparently I should be able to yaw the thing whilst it continues to fly the mission, which sounds kind of cool.
Motors armed.
Yeah, so I can keep it pointing inwards, or I can even go all the way around and have it point outwards, so it's now flying backwards. So I'm giving it left yaw, and the whole copter is spinning left whilst it flies the circle via the waypoints. That's kind of cool, actually. I like that. And the other way. That's kind of cool, I like that. Not particularly useful, but, well, not useful like this. Useful for pointing a camera or a sensor the right direction.
Motors disarmed.
375. That was fun. I enjoyed that.